Hi, it's Mrs. Pope, and today we're going to talk about solving quadratics. So we've been spending a little bit of time factoring quadratics, but now we're actually going to set them equal to 0 and solve them. That means we're going to find where they cross the x-axis. There are solutions, and we have three possible solutions of a quadratic equation. So of course, the graphs of all quadratics are parabolas. The ones that I've drawn here happen to be where a, the coefficient of x squared, is positive. That's why they're all opening up. So that's something important to listen to, hopefully if you're listening, to understand the last part that you have to do today. These are all where a is greater than 0, that's why they're facing up. So anyway, you could have three options. Either there are going to be 0 real solutions, which makes sense because it never crosses the x-axis, which also means there are 2 imaginary solutions, going with the imaginary numbers. Then we could also have 1 real solution. It only touches in 1 point. It's called a double root. It actually goes down, touches the x-axis in exactly 1 point, goes back up. Or we could have 2 real solutions. This is the most popular method, I guess, or the most popular answer, where we have 2 answers, 2 solutions. It usually crosses the x-axis, at 1 point hits a minimum or a maximum, in this case a minimum, and then crosses the x-axis again. 2 real solutions. Also remember, we call solutions zeros or roots, all the same. Okay, so let's look at some examples. Example 1. We're going to solve this quadratic. And the first thing you want to do is factor it. I'm not going to go through the factoring steps because we've already factored it. But first step is to factor. And this is factoring where a is not equal to 1. If you need to review your factoring, that's where you would go back to. Step 2, we're going to set each equal to 0. And step 3, we're going to solve. So if you factored this, I'm just telling you now, if you factored it, you would have gotten, and maybe you could pause and factor it, see if you get what I get. Negative 3x plus 2 would be one of the factors, and x plus 4 would be the other. Now, that means we factored it. Set equal to 0. You need to set each parenthesis equal to 0. Why? Well, something called the zero product property rule. It's a rule that you already know, but anything times 0 is, of course, 0. So if I'm trying to make this equal to 0, all of this, if I made this entire parenthesis 0, who cares what's in the other one? Because 0 times who cares would be 0. Or if I made this parenthesis equal to 0, a big old 0 right here, who cares what that is? Because as soon as it's multiplied by 0, it'd be 0. So what we're going to do is set each one of these equal to 0. That would make me happy because that would knock that out. Or this would make me happy because it would knock that out. Solving, we'd subtract 2 from both sides, of course. Negative 3x equals negative 2. Divide by negative 3. X is equal to 2/3. That's one of the solutions. Think about it. If you put that in there, you would get negative 2. If you multiply that, plus 2 would be 0. Or subtract 4 from both sides. X is equal to negative 4. So the 2 answers are 2/3 0 as an ordered pair, and also negative 4 0 as an ordered pair. These are the 2 places where it crosses the x-axis. Well, I can look at this. I'm going to sketch it. It does not have to be perfect. If you have a graphing calculator, you can put it in and see what it looks like, or we can just sketch it. Negative means it's going to be facing down, and I know it's going to cross through negative 4, so somewhere around there, and then 2/3, something less than 1. So there's 1, let's say it crosses here, it faces down, it's going to look something like that. Now you can make a table to get the exact, you can find the vertex to get this point, but this is a sketch. You know it goes through these 2 points. There are 2 solutions. All right, let's look at another example. X squared minus 8x plus 12. So we're going to factor it, set each one equal to 0, solve them. And then we're going to sketch as well. So this factors into x minus 6, x minus 2, and then we're going to set each one equal to 0. So x minus 6 equals 0, x minus 2 equals 0. Of course, this just means x is going to be 6, x is going to be 2. So my answers are 6, 0, and 2, 0. If you were to sketch it, it's going to open up So it's going to have a minimum somewhere down at the bottom. It's going to go through 2 and 6. So one time it's going to go through 2 on the x-axis, the other one's going to go through 6. I want you to sketch that, and I'll check it in your notes to see how it went. All right, a little bit on your own to do. So the 3 possible solutions that we talked about in the beginning of the video, you could either have 0 real solutions where it doesn't touch the x-axis, 1 real solution where it touches 1 time, or 2 where it crosses twice. I want you to sketch 3 examples, 3 graphs, but all of yours, notice, are A is less than 0. So that means A is negative. You need to know what that means. They're going to be kind of opposite of the ones I did in the beginning. That should be enough hints for you to get this done, and I'll check it in your notes. Thanks for watching, and remember, you are responsible for your own learning.